Hello everyone, I'm Arindam Chakravarti, Assistant Professor of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. In today's session, we'll learn about design. We'll also learn how design has been evolved, and we'll also learn how design is turned or converted to a manufacturing process. Now, at first, what we have to know, what is design? As per the dictionary, the definition states that it's a plan or a drawing, or if we elaborate it, it's a representation. What about your process? Your process, or it may be your uh, a component, or it may be anything. It may be a building, it could be a machine, even it's in garments also, like the garment, is this dress fits or not. So we are nothing but designing it. So we, as well as the decorations what we make, like in Burj Khalifa, so we have Petronas towers in Malaysia. So we are nothing but design is also over there. So design is a multicultural things. So what does design provides? What things we can get from design? Number one, functionality. What does the system does? What is the process, and what are the else? As well as we get a message that this diameter is that's one or something. It provides a design like the traffic symbols. It's nothing but a design, small designs which has been made. It gives a message that school is ahead. You have to slow down your vehicle. Professionalism, like you are preparing a PPT, or you are submitting your thesis, so you will maintain some decorum. So that's what comes, that's also a part of design. Next, branding, like what we do in branding a mobile phone or any of the products. So we use accessibility, like how it could be accessible. Like if you make a pen, is it can you hold it? How much time you can hold it? So this thing is relative to each other. Now, engaging. So design is something which is related to marketing also, which engages you to this component, to this product or these things. As well as it have broader, like it makes things simpler to understand, like the boarding pass. You could see in the boarding, sorry, not the boarding pass, the safety brochure which is given in aircraft while you board over there. So there it is written that how you, if in case of emergency you have to slide down or something. So there's a written over there. That's a representation. So that's also one type of design. Usability, how you are using. So this is all about, this is design has a multicultural thing, as I have told you earlier. Now, history. Now the question comes, history. Now the thing is that the most important thing has the design evolved from somewhere else, like or we have created a design. That means in short, like, did we make this subject, or it has been evolved, or it has been in our nature for decades and decades. So everything we don't know. So the thing is that design is something which has started at the time of a Big Bang itself. Now, why I am telling that? Now, try to observe the Milky Way galaxy. Now, it's have a spiral thing, like it's something like a spring, as well as it's circular in object. So you will be finding the our solar system, that our Earth is circular. Everything there's a ring on Saturn, with Saturn. So there are a lot of things you could, if I start defining it, it's a lot of things. Even Earth, revolves around the sun at elliptical path. So the thing is that everything is in symmetry in entire universe. Everything is in symmetry. That means the design has been created from there itself. So what we are thinking over here, like design is a subject which we have made. No, it's not made subject. It had been from years and years and years. After that, we have just collected the all amount of things, and we are describing in our books. and as you can see in the solar system also, everything is in circular in object. Why it could be a rectangular? Why can't it could be a cubical in shape? So why can't be a cylindrical shape? So why it is a circular? Because circle is the most circle or sphere is the most most stable structure in design or geometry. So this is what that means. It has been evolved from the time of Big Bang itself. Now the tools made by our cavemen, now you can see that this tools, let me get my just a minute pointer, that would be much more better. Okay, so this point, this as you can see, the tools what we have there, that's made by the cavemen, these are also innovative. That means this, they have made the design, they came up with a sharp end, they came to, okay fine, the sharp end could help me out for killing and hunting the animals, and we could feed on them. So after that this is the modern 3D CAD design what we do after lots of calculations. So it's not about drawing or something representing, it's about calculations also. You have to go about the calculation. Now this is all about the 3D models what we in present days we do. Now as you can see, this is a product what we can do by, it has been manufactured by CNC. So it has been evolved from the calculations, how much radius shall I kept, how much distance shall I kept. So it all have the calculations, but all have been and done from a computer to a your practical idea. Fine. Next. Now Rini AU has stated that if you design something like a refrigerator, if the design is well enough, it will be very good. If it is not well enough, or it's not, design is not perfect, that means there will be a lot of problem. Like a refrigerator, if the refrigerator doesn't work, the things which you have kept over to refrigerate or to get freeze, it will stink. There will be there will be a smell, there will be a bad smell. But if it works, it will not smell. So that's why he stated that good design is like a refrigerator. When it works, no one notices, but when it doesn't, it stinks. That means there will be a bad smell. So that's the thing with design also. If it's a wrong design, or if it's a design, there is a flaw in design, everyone will notice. Like in Boeing 737 Max, everyone has noticed that there is a problem with the system. So this is what happens. Next, what are the types of design? Designs has been basically divided into two categories. One is structural design, another one is decorative design. Now what in terms of origin of manufacturing, so there are two types, natural and man-made. Natural is, you know, that like our leaves, like the earth, like the planets, as well as like our hills. So everything, our galaxies, everything is natural. And man-made is like mechanical, what we do, we make car, we make aircraft, we make everything. So mechanical is something like that. Electrical is like electrical, what we do, electrical networks, where we use electrical transformers. Civil, we know that making of homes, making of houses, homes, that all construction is. So on it goes on. So method of design. So there are two types of method we do. One is 2-dimension and one is 3-dimension, and after that we do plotting. One is manual plotting, another is electronic plotting. One is done on sheet, another one is done in software. So but before that, you need to know that while designing all these things, you have to go through some mathematical calculation. It's not that you started designing something like out of nothing. There are a lot of things you have to go beyond it, but it's all easy to understand if you go on study or explore the things. So how this journey starts? Now you have a concept that you need to make one aircraft, make one car. So what you have a concept. So what after that you did, you prepared that your concept in a 3D model by using software, as I have shown you over here. That's 3D softwares. Fine. So it's a modern age manufacturing process. It is somehow same like the earlier ones also, but I'll be telling you what used to happen in the earlier age. So what is happening is that after 3D model has been created, it is simulated by using other softwares, or it is simulated by using your pen and pencil. It has been done with both. After that, it has been if it passes the simulation analysis, it goes for prototype testing. Like a prototype is made, or something in a simple word. A replica is made according to the 3D model presented, and if it passes, okay, it will go for manufacturing. If it not, it will again go for 3D model, and they will spot out the problems where they have failed to do this one. Again, they will 3D model it, or they will rectify the 3D model. Again, they will go for the same thing, simulation analysis, by using a computer, as well as by using pen and paper. Then it comes to prototyping. So this is similar to the ancient type also. So what is happening used to happen in the earlier days, before software was not there, simulation software was not there, like ANSYS, ANSYS, Abacus, COMSOL. So what we used to do is that we used to have a conceptual design. Then after we used to draw the 3D model with hands. Here we used to do entirely with pen and pencil. There used to have no computer, nothing to do. Fine. Now, software based design concept, and we know that it is very easy to interrupt. It's a simple thing. There are for software based computer designs, we have to learn one more topic that would be taught in further classes, that is finite element method. Again, that software based system can be latched with CNC, that is computer numerical control. That is nothing but automatic manufacturing process, and you don't need to make the physical model that used to be done in the earlier days. It is very easy to create. You could alter it, you could edit it, as well as it could be used for presentation and marketing. Like you have dummy mobile phones in a mobile phone store. That is nothing but you are making a presentation or marketing. You could do by 3D model also. So it's very, very simple. So there is, as I have told you, a topic about finite element methods. It's a very simple. Don't make it very. You don't have to learn right now. We'll be discussing about in the upcoming topics. Now, what is that? Finite element methods is having is nothing but analysis of a part or a section in smaller division. That means if you have 10 mm by 10 mm square, you will be dividing in 4 halves or 7 halves or million of halves. After that, what you will be doing, you will be analyzing for each block, and you will be getting the answer. What happens is that this makes a distributive knowledge regarding stress and strain, that explains what will happen, where the actual stress can happen, how the stress is transferred from one point of the body to another point of it. So it gives a brief idea about the design and diagrams, everything. Fine. So this comes with a new, for example, that's why I'm giving you one more example that would be for today. So this is where the design situation starts, that is termed as design synthesis. What is design synthesis? It is nothing but, as I have told you, it's a manufacturing process only, but from the design to manufacture, there is something to be kept, what to be kept and what not to be, should be considered as a constant, what should not be considered as a constant. This is where the synthesis comes. That means where you can change, where you can alter it, if the things come. Now, for example, let us take an example of Coke can, that is Coca-Cola cans. What we used to do, this is similar for every, the diameter of the can is similar for every can which you buy. Like you buy thousands of cans, you will be finding the similar diameter. So what happens is that you will be that similar diameter have to be maintained to protect the pressure, or to resist the pressure, to or to, by from which it will not deform due to the high pressure. So that is a simple word. To be in other words, you can say that the minimum diameter required to be maintained for each and every can, such that the pressure generated inside a cold drinks can should not explode or something. That should not be deformed. The body should not be deformed. So this is what happening. That means you can synthesize it. Like as you can see, these are the cans. These are the cans for color coating cans. So what we use, you can get in the market. So every one is having a similar diameter. So this is what R max. That means the diameter will be same, for similar diameter will be kept. There will be the thing is that the maximum target is kept, that the diameter will be similar for everyone. That means there will be less tolerance, very less tolerance will be allowed. Like diameter is 15 mm, so that will be 15. There may be tolerance like 14.95, 14.92, or 14.2, 14.8. So they have a tolerance, very less tolerance. You could for that you need precision on testing elements. Fine. Okay, that is where the design process is. Synthesis is done. Now let us go for a small review how it works for design process. For a simple, let us consider a mobile phone. So the mobile, for which we'll understand with an example that will give a more broader view. So what is happening is that a mobile phone company is will be serving the on the market, or to the market. So what are the after serving, they will define their specification, nothing but they will study about the specification, what specification is required and what else not. After that they will study for they will go for searching this product. Do we have that product, or do we have to have this type of product or not? If it is there, so we'll be updating it. If it is not there, we'll be creating it. That's done. After that, the thing is that if it is updating, where it will be updating, and everything will be layouted, and everything will be what are the components it's required and what else not. This will be generated over here, or this will be calculated over there. After that, this individual components are will be designed. That means the upgradation or the new components which you need, or the new product, they will be, everything will be developed over here, and a prototype will be made. For after that, then the prototype will be again tested. If it doesn't satisfy, it will again go for over here. They will check for the components, the design, the drawing, the diagram. After that, they will again come and they will wait for the certification. Now, if I go for more depth thing, that means in terms of engineering, that's all about marketing or management part. But if I go for mechanical part, so what we do is that we specify an element like a mobile phone lock switch. So what we do is that we keep on mind that how many times you can press it. Also, we will see that how much force we are actuating. So on that key. So what is happening is that. You have to will be finding the average force which is applied by this by our thumb to our lock key. After that, we'll be saying that whether what will be a suitable material to withstand that force. After that, we will see, it will be observing the failure methods, how it will fail and what else not. Will that key fail with 10 time pressing, or it will be failing after pressing it will be after 10,000 times or 1 lakh times. So that will be denoted. After that, if required, the geometric dimensions will be changed, will be altered, or a new geometrical dimensions, the old geometrical dimensions will be kept. So that depends on entirely what model you are using. After that, the modification will be cross-checked and they will be, everything will be checked whether it is working or not. After that, it will go for further manufacturing and, or analysis in the queue of manufacturing process. Okay. Now this is for today. In next session we'll learn about how model, how designs comes in action. As well as we learn about the forces, as I have told you, because we are in mechanical engineering, so we'll learn about the forces which is acting, and we will discuss how it works, how many forces are there, and there you will be learning about the new forces which are acting on a body, which you have not studied earlier. Thank you. Have a nice day.